Welcome to Part 3 of the Android Interview Series 2024, focusing on Kotlin basics. Whether you're preparing for an interview or just starting your journey with Kotlin, this video will guide you through the core concepts every Android developer should know. We'll cover everything from variable declarations to advanced features like inline functions, extension functions, and memory management. By the end, you'll have a solid foundation to tackle Kotlin questions confidently. Let's dive in and explore why Kotlin has become the preferred language for Android development, offering modern syntax, safety, and seamless Java compatibility. Kotlin is now a staple in Android interviews. Its concise syntax and safety features make it a favorite among developers and interviewers alike. In this section, we'll outline the structure of the interview series, highlighting how Kotlin fits into the broader Android ecosystem. You'll see how topics progress from Android basics to advanced Kotlin concepts, ensuring you're well prepared for any technical discussion. Understanding Kotlin basics is crucial, as it forms the foundation for more advanced topics like coroutines and Jetpack Compose. Kotlin is a modern programming language that runs on the Java Virtual Machine, JVM. It's fully compatible with Java, allowing developers to use Kotlin alongside existing Java code seamlessly. This compatibility is a major advantage, making migration and integration straightforward. Kotlin's syntax is concise, expressive, and designed to reduce boilerplate code. Its safety features, such as null safety, help prevent common programming errors. As Android's official language, Kotlin empowers developers to build robust, maintainable apps efficiently. In Kotlin, variables can be declared using either val or var. The var keyword creates a mutable variable, meaning its value can be changed after assignment. On the other hand, val declares a read-only variable, similar to final variable in Java. Once assigned, a val variable cannot be changed. Choosing between val and var is important for code clarity and safety. Using val wherever possible encourages immutability, reducing bugs and making your code easier to reason about. The const keyword in Kotlin is used to declare compile-time constants. A variable declared with const val must be assigned a value at the time of declaration and cannot be changed afterward. It's more restrictive than val and can only be used with primitive types and strings. Const is ideal for values that should never change, such as configuration constants or static values. Using const ensures that these values are embedded directly into the compiled code, improving performance and reliability. The latinate keyword allows you to initialize properties after object creation, which is useful for properties that cannot be initialized in the constructor. Latinate properties must be initialized before access, or an exception will be thrown. This is commonly used in Android development, such as initializing recycler-view adapters inside fragments. Latinate helps avoid unnecessary null checks and keeps your code clean, but it requires careful management to ensure properties are properly initialized before use. Kotlin provides 4 visibility modifiers: public, private, protected, and internal. Public is the default, allowing access from anywhere in the project. Private restricts visibility to the containing scope, such as a file or class. Protected allows access within the class and its subclasses. Internal restricts visibility to the same module. Understanding these modifiers is essential for controlling access to your code and maintaining encapsulation, which is a key principle in object-oriented programming. Anonymous functions in Kotlin are functions without a name. They can be passed as values, similar to lambda expressions. Anonymous functions are useful for creating flexible, reusable code blocks that can be executed on demand. For example, you can define a sum function as an anonymous function and assign it to a variable. This approach is powerful in functional programming, enabling higher-order functions and concise code. Higher-order functions are functions that take other functions as parameters, return functions, or both. They enable abstract and flexible code structures, making it easier to build reusable components. For example, a custom filter function can accept a predicate function to filter a list. Higher-order functions are central to Kotlin's functional programming capabilities, allowing developers to write expressive, modular code. Inline functions reduce the overhead of higher-order functions by copying the code of the function parameter directly into the call site. When a function is marked as inline, the compiler replaces function calls with the actual code at compile time, improving performance and reducing memory allocations. Inline functions are especially useful for small, frequently called functions, and when passing lambdas as arguments. This optimization is crucial for performance-sensitive Android applications. The main difference between inline and regular functions is how they handle lambda parameters. Regular functions create an instance of an anonymous class for the lambda, while inline functions combine the calling code and the function code directly at the call location. This eliminates the need for anonymous class creation, reducing memory usage and improving performance. Understanding this distinction helps you decide when to use inline functions for optimal efficiency. Inline functions are best used for small, frequently called functions that are critical to performance. They are also useful when a function is used as an argument to another function. By inlining these functions, you minimize overhead and maximize efficiency. However, avoid inlining large functions, as it can increase code size and reduce readability. Use inline judiciously to balance performance and maintainability. The cross-inline keyword is used in inline functions to ensure that the lambda parameter cannot use non-local returns. This restriction is helpful when the lambda is passed into another function or coroutine, preventing unexpected behavior. Cross-inline maintains the benefits of inlining while controlling the lambda's behavior, making your code safer and more predictable in complex scenarios. The non-inline keyword is used when you have an inline function, but don't want all lambda parameters to be inlined. By marking a lambda with non-inline, you instruct Kotlin not to inline that specific parameter. This is useful when you need to pass the lambda to other functions, or when inlining isn't appropriate for certain parameters. Non-inline provides flexibility in optimizing your code. Reified types allow you to use actual type information at runtime within inline functions. Normally, type information is erased at runtime, but reified keeps it accessible. This is especially useful for tasks like JSON parsing, type checking, and dependency injection. By marking a function as inline and using reified, you can work with generics more effectively, simplifying code and enhancing runtime capabilities. Extension functions let you add new functionality to existing classes without modifying their source code. This feature enables you to extend classes with custom methods, making your code more expressive and reusable. For example, you can add a word count function to the string class, allowing you to count words easily. Extension functions are a powerful tool for enhancing code readability and maintainability. Scope functions allow you to execute a block of code within the context of an object. Kotlin offers 5 main scope functions: let, run, with, apply, and also. These functions help you initialize, configure, or transform objects concisely. For example, let is used for null checks, run for transformations, with for configuration, apply for initialization, and also for additional operations. Mastering scope functions streamlines your code and improves clarity. The use function is a scoped function designed for working with closable resources like files, streams, or database connections. It ensures that the resource is closed automatically after the block of code is executed, even if an exception occurs. This prevents resource leaks and simplifies resource management. Using use is essential for safe and efficient handling of resources in Android development. A type alias in Kotlin provides an alternative name for an existing type, making your code more readable and expressive. It doesn't create a new type, but allows you to refer to complex types with simpler names. Type aliases are especially useful when dealing with collections or data models, helping you write cleaner and more maintainable code. Infix functions allow you to call functions in a more natural, readable way, similar to operators. They are called using infix notation, without the usual dot or parentheses. This feature makes your code more expressive and easier to understand. Kotlin's standard library includes several infix functions, such as to, until, and down to, which simplify common operations. The by keyword is used for delegation, allowing one object to delegate functionality to another. This reduces boilerplate and enables code reuse. Delegating properties, such as by lazy, initialize a property only when accessed. Delegating interfaces lets you reuse implementations without redefining them. Delegation is a powerful feature for building flexible and maintainable code structures. Stack memory in Kotlin stores temporary variables created by functions, including primitive data types and references to objects. Each function call creates a new stack frame, which is removed when the function returns. Stack memory is fast, limited in size, and managed automatically by the JVM. Understanding stack memory is essential for optimizing performance and managing local variables effectively. Heap memory is used for dynamic memory allocation in Kotlin. Objects and larger data structures are stored here, while references are kept on the stack. Heap memory is managed by garbage collection, allowing objects to persist beyond function calls. Understanding the distinction between stack and heap memory helps you write efficient, memory-safe code, especially when working with objects and collections. Stack and heap memory serve different purposes in Kotlin. Stack is used for static memory allocation and local variables, while heap is for dynamic allocation and objects. Stack is faster but limited in size, whereas heap can grow as needed but is slower due to garbage collection. Understanding when to use each type of memory is crucial for optimizing your app's performance and managing resources efficiently. For primitive types like int, double, and boolean, Kotlin uses JVM primitives to save memory and improve performance. When a primitive type is made nullable, Kotlin boxes it, wrapping the primitive in an object form. This allows it to represent both the value and null, but consumes more memory. Nullable types are typically stored on the heap, requiring additional metadata to indicate their nullability. The equals equals operator checks structural equality, comparing the content or values of two objects. The equals 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 operator checks referential equality, determining if two references point to the same object in memory. Understanding the difference between these operators helps you avoid subtle bugs and write correct comparison logic in your Kotlin code. Creating a singleton class in Kotlin is simple using the object keyword. This ensures only one instance of the class exists, lazily initialized when first accessed. Singleton classes are commonly used for managing shared resources, such as API clients or configuration objects. Kotlin's object declaration makes singleton implementation straightforward and efficient. Kotlin provides a variety of operations to work with lists efficiently. You can add, remove, filter, map, and sort elements with concise syntax. Lists are fundamental collections in Kotlin, supporting both mutable and immutable variants. Mastering list operations is essential for handling data and building responsive Android applications. Maps in Kotlin are collections of key-value pairs, offering efficient ways to store and retrieve data. You can perform operations like adding, removing, filtering, and transforming entries. Maps are widely used for configuration, caching, and managing relationships between data. Understanding map operations helps you build scalable and maintainable applications. Sets are collections that contain unique elements. Kotlin provides various operations to work with sets, such as adding, removing, and checking for membership. Sets are useful for ensuring uniqueness and managing distinct data. Mastering set operations is important for tasks like filtering duplicates and handling collections efficiently. Sealed classes represent a restricted hierarchy where all possible subclasses are known at compile time. They are ideal for modeling restricted data types or state hierarchies, ensuring all cases are handled safely. Sealed classes make code safer and more expressive, especially when using when expressions to handle different states. Sealed interfaces are similar to sealed classes, but allow more flexibility by enabling classes or objects to implement the interface. This is useful for restricting implementations to a known set while allowing different types to participate. Sealed interfaces enhance safety and maintainability in complex data models. Data classes are designed to hold data and automatically provide useful functionalities like equals, hashcode, toString, and copy methods. They are typically used to create immutable objects, reducing boilerplate and making your code more concise. Data classes are essential for modeling data in Android applications, supporting destructuring and easy manipulation. Companion object is a special object associated with a class, allowing you to define properties and functions directly within the class. Companion objects act like static members in Java, but are more flexible. They are used for holding methods and properties common to all instances, such as counters or factory methods. Abstract classes cannot be instantiated on their own and serve as base classes for other classes. They allow you to define abstract methods and properties that must be implemented by subclasses. Abstract classes can also contain concrete methods, making them versatile for building reusable code structures in Android development. Generic classes can work with different data types, making your code more flexible and reusable. By defining type parameters, you can operate on any data type specified at instantiation. Generics provide compile-time type safety, reducing the need for casting and preventing type errors. Constraints can be set to restrict type parameters, enhancing reliability. The open keyword allows classes and members to be inherited or overridden. By default, all classes, functions, and properties in Kotlin are final, meaning they cannot be extended. Using open enables inheritance and customization, making your code more flexible and extensible. This is different from Java, where inheritance is the default. Kotlin doesn't support multiple inheritance by classes to avoid complexity and ambiguity, known as the diamond problem. Instead, Kotlin allows classes to implement multiple interfaces, which can contain default method implementations. This approach enables multiple inheritance of behavior without the ambiguity associated with multiple class inheritance. We've covered the essential Kotlin basics every Android developer should know. From variable declarations and visibility modifiers to advanced concepts like inline functions, extension functions, and memory management, these topics form the foundation for building robust Android applications. Understanding these basics prepares you for interviews and real-world development challenges. Applying Kotlin basics in real-world Android development is crucial. Whether you're building user interfaces, managing data, or optimizing performance, these concepts help you write clean, efficient, and maintainable code. Practice using these features in your projects to gain confidence and mastery. Preparing for Android interviews requires a solid understanding of Kotlin basics. Review key concepts, practice coding exercises, and understand how to apply these features in real scenarios. Focus on clarity, correctness, and efficiency in your answers. Familiarity with Kotlin's unique features will set you apart from other candidates. There are many resources available for learning Kotlin, including official documentation, online courses, and community forums. Engage with the Android developer community, participate in discussions, and seek feedback on your code. Continuous learning and practice are key to mastering Kotlin and succeeding in interviews. Explore articles from Android professionals and Google developer experts for deeper insights into Kotlin and Android development. These articles cover advanced topics, common pitfalls, and best practices. Staying updated with industry trends and expert advice will enhance your skills and knowledge. Engage with the Android developer community by following experts, joining forums, and participating in events. Networking helps you stay informed, share knowledge, and grow professionally. Building connections with other developers can lead to new opportunities and collaborative projects. Thank you for watching this comprehensive guide to Kotlin basics for Android interviews. Continue exploring advanced topics like coroutines, flows, and Jetpack Compose to further enhance your skills. Stay curious, keep coding, and embrace the evolving world of Android development. Good luck with your interviews and happy coding.